Good evening and welcome to the latest in our webinar series, which is aligned with the Timber Development UK Southside Hereford University Design Challenge for 2022, which is in partnership with Passivhaus Trust, Edinburgh Napier University, and the New Model Institute for Technology and Engineering, which happens to be in Hereford and indeed is one of the stakeholder partners for the project. The challenge itself, we have a selection of sponsors, which you can see along the bottom of the slide there. Our sort of headline sponsor is Transforming Timber, which is actually a live project at Edinburgh Napier University at the moment, looking to accelerate the utilisation of homegrown or UK sourced timber into construction in the built environment. And indeed, there'll be a future webinar on that very topic. And we have a series of other good sponsors also, some of which are providing cash for the prizes, or indeed to sponsor the event which we'll be hosting in Hereford later on in the year, which we're currently going through the organisation of, and we look forward to welcoming the sort of the entrance of the challenge, or at least the high performing entrance of the challenge to that, and we'll be announcing the winner at it. And we also have a series of software providers, including Trimble, and the software that you'll be able to utilise within the competition itself. So lots of good stuff in the mix. And yeah, with regards to the challenge itself, we're working across multidisciplinary, interdisciplinary teams across universities, encouraging learners to sign up. I understand there's 100+ learners at this stage, which are forming into groups, and those groups aren't isolated into teams as such that are from specific universities. They can cut across different universities, or they can be from one specifically. And indeed, we're actively encouraging students to work across universities to broaden your network and your experiences, and the digital tools that we have at our availability now certainly facilitate that. But anyway, the basis of the competition is to design a new community hub facility for growing local organic food and sort of kitchen skills, cooking skills partner. Belmont Rovers, who are a football club in the area, who do junior football all the way up to the sort of senior teams for male and female, etc. But yeah, it cuts across the community there, and they have football pitches and sort of current facilities which are kind of a bit run down, etc. And then NMITE in itself, who are actively engaged with these two partners because of the role that they want to play in Hereford and indeed the south side part of Hereford, and to sort of almost like give back to the community itself. So they're partnering on that perspective. The spaces to be created in this sort of community hub is obviously to host these partners and their needs in a sort of 800 metre squared building. There's a budget for it, it's 1.6 million, and this is indeed a live project, right? So there's opportunity for the work that's undertaken by the students to inform the ultimate design of it, and that's currently going through the sort of business planning and procurement processes, as we speak as such. And what you see in front of you here really is just an artistic impression. So this actually shouldn't inform what you come up with via the designs that you undertake. It's purely to act as a sort of visual representation of what they're looking to create and bring together and fuse within the building itself. So the building is to be a focal point for these partners, for the community, and represents a really unique opportunity whereby you're bringing health and well-being in terms of food aspects as well as sports skills, and then from an NMITE perspective, what this means in terms of sort of upskilling and reskilling and so on. The information, so we're recording this evening, and all the webinars indeed have been recorded, and they're on a YouTube channel. So the links we will post in the chat. We have a website which is hosted on the current TRADA website, because TD UK is the merger of TRADA and Timber Trades Federation. So all the information with regards to the competition can be found via the website link. And indeed, you can look at last year's competition, which was based in Sunderland, to see previous webinars, as well as the outputs from those that participated within that challenge. And of course, you can, if you haven't already done so, you can book up for the future webinars via the Eventbrite booking. And just to mention as well, Tabitha of Timber Development UK also hosts a virtual pub and a WhatsApp group as well, to encourage the sort of getting together of those that are participating in the challenge, and indeed others, to share knowledge, and as well also to help form the teams, as well as post information that becomes available during the course of the challenge. So that's hopefully give you some context and some background, but that's really pretty much from me. What I'll be doing now is handing over to our speakers. And tonight is obviously about timber buildings, but getting it right on site. And hopefully you'll take cognizance of the tips and that come from this webinar in terms of how you create the design, because it's not just about how you design, but it's ultimately how you deliver it, and also how you ensure that building has durability. So hence why moisture management is absolutely key, given we're looking at timber, and Robin will run you through moisture management and durability of timber structures. We want the building itself to be of a Passivhaus standard. So we want you to design and detail it to maximise the thermal performance, reduce cold bridging, air tightness, etc. And Jay Cotterell of the Passivhaus Homes will give you an insight into that, and indeed how to ensure the buildings perform as intended, or indeed as predicted. And then, of course, I think this brings us also to the fore is getting it right on site. And what we want to do here also is create a building, but create a sustainable community and a community entity. So Jamie Keates from CITU will give you an overview of the work that they're doing in Leeds and in Leeds Dockland, etc., in terms of how they're building sustainable communities there using off-site and pre-manufactured approaches. And then we'll round it off with group discussion, Q&A, and yeah, Tabitha and I will hold on also, and indeed if there's further questions or queries or anything we can do to facilitate the team building exercise. So with that, I will stop sharing and hand over to Robin, so he can provide his presentation on moisture management and durability. So over to you, Robin. And you're on mute, Robin.
Somebody put me on mute. Great. So my task for the next 20 minutes is to talk to you about moisture management and durability of timber. And the slide says in construction and in use, but actually what I want you to think about is what goes before construction, design, construction and use. I've worked for TRADA and BM TRADA for 20 years now, and we get a lot of questions and can provide a lot of answers through all the information we provide. But one of the many repeatable questions we get is, how long will a timber frame building last? There are examples around the world of many hundreds of years, actually. But the answer is really, depending on how well it's designed, constructed and maintained, it will go on depending on those three factors. And if you get them right, it's as long as you want it to. So on the screen, you've got two pictures there of a CLT building under construction on the left-hand side, and then the finished building on the right-hand side. And really, as the talk rolls on, what I want you to think about are those three aspects of design, construction, and in use, and putting timber in a position where it's going to be able to last as long as you want it to. Why has Tabitha asked me to come along and talk to you all today? Well, really because of my area of expertise in timber frame buildings, and we provide that through the frame check service that BM TRADA run, and we are independent experts on timber frame construction. We do that in a variety of ways. We run training courses in normal times up and down the country, but also from our base in High Wycombe, where we train anybody and everybody, everything from architects, engineers, building control, contractors, timber frame erectors, anybody who's got an interest in timber frame construction. We produce lots of information through our publications team, and the book on the right hand side there, Timber Frame Construction, really, it's really the flagship publication for platform timber frame in the UK. And the popular site check timber frame pocket guide that's co-produced for the Structural Timber Association is also a useful handbook on detailing. So as part of your student membership to TRADA, you will have access to those through the website. We also provide commercial services for design evaluations. So that's take a stack of drawings that an architect has produced and build that construction in our minds, and report back to the client on things that we think they could do better, maybe from a design detailing point of view, maybe from a workmanship point of view. And more now, health and safety is becoming an issue as well in order of work, to try and make sure that what an architect actually draws can actually be built. We also look at buildings under construction up and down the country, key points during the build where we can advise clients on things that could be done better, either on that project or perhaps on the next project, order of work. And we are there as timber's friend to point out things that could be done better to make sure the buildings last as long as we want them to. Sometimes things do go wrong, and our defects and remedial consultancy is useful not just to our clients, but actually also to us, because it underlines many of the things that we talk about, and gives them a sense of reality and purpose and assurance that what we say actually does matter when we see things that people haven't followed our advice and they end up with problems. Regardless of how much you know about timber, you probably know that it rots, but it only rots if it's an environment where it is that decay can happen. And the magic number for moisture content is 20%. Timber is maintained at a moisture content in excess of 20% for a prolonged period of time, then decay can start. So timber has been wet during its lifetime growing, so it's used to dealing with moisture. It has a good transport mechanism for moving moisture around, and unfortunately that can also play to the detriment of timber in construction and in use, in trapping and allowing moisture to travel in timber. So we need to make sure that timber is maintained in an environment where it can breathe, and if it gets wet in the short term, can dry out quickly to keep it below that magic 20% moisture content. Now, the picture on the left-hand side is a garden shed. It's on a grey slab, and you can see what we talk about, we'll call the splash zone. Rainwater landing on those slabs bounces back up, and you can see the bottom piece of timber on that shed is a darker colour where mold growth and fungal decay can start, because it's an environment where it's above that 20% for a prolonged period of time. When we build a timber frame, we want to make sure that our buildings and our claddings are above that splash zone. And if you look on the left-hand side of that same photograph, you can see that building's got timber cladding, and it's raised up off the ground by at least 150, 200 millimetres. So it's out of that splash zone. So it's not an environment where it's going to stay above that decay threshold. The centre picture is of a fence post. Again, it might be something you're familiar with in the domestic setting. Look at where decay has occurred and where that fence post has snapped. It's snapped at ground level. So when you look at a fence in your garden, it's not the fence panels themselves or the full height of the post that's often decaying. It's at the bottom. It's where timber is, again, it's constantly wetting. It's got the food from the soils. It's got access to insects and fungal growth down there. And so that timber actually is working really hard to not decay, but eventually, even with preservative treatment, it does suffer and decay. So in our timber frame buildings, again, what we're looking to do is make sure that that environment I've just described at the base of that fence post isn't present, and we can deal with keeping decay at bay. And then on the right-hand side, you can see a timber frame building. You're looking at an OSB floor joist, an OSB sheathing, or OSB is oriented strand board, strands of timber that are compressed together to make a board that's often used in timber frame construction. And it has got wet for a fairly small leak, but for a prolonged period of time. And you can see the fungal decay there. You can see the damage setting in. So we want to make sure that our buildings don't leak in use and end up with problems that can look like that over time. It's useful to reflect on what preservative treated timber, what you can expect from preservative treated timber, because a lot of people think that throwing some preservative at it, and by throwing I mean brush applying perhaps, turns it into some magical material that resists decay and you can do anything with. And that's far from the truth. Preservative treating timber buys you time. It does add a level of durability to timber, but eventually if timber is an environment where it is getting wet and staying wet, timber will decay. So the building regulations in the UK tell us that we should treat timber when it's in an environment where it is difficult and expensive to replace. And so we generally will therefore treat pieces of timber like you can see the sole plates and the bottom rails there on the bottom of a wall panel of a timber frame building. Actually, what tends to happen is the bulk of our timber in the UK gets treated because warranty providers are a little more nervous, and the treatment is quite cheap and easy to apply. And so many timber frame buildings that you see have all of their timber treated. Although cross-laminated timber is a current one that we don't preservative treat, and sheathing boards like OSB again don't have preservative treatment. So you can see that some timbers on site are treated and others are not. Around the world, many people don't treat their timber at all, and they rely on what this talk is about is good design, good construction and maintenance to avoid timber getting wet and needing to rely on the additional durability that preservative treatment gives us. Different types of timbers have different levels of durability, and different types of timbers absorb preservative in different ways. Some of them are quite resistant to it. So it's quite a tricky game, knowing the type of timber you've got and how durable it is, and how much it's likely to absorb any additional preservative treatment you add to it. And TRADA have got quite a lot of information on that. But preservative really is very much an envelope treatment. It's a bit like wrapping up a Christmas present. The wrapping paper or preservative treatment is only on those outer faces. And if you cut through preservative treated timber, you cut through the present, you're exposing what's inside, and that is untreated. So if you cut preservative treated timber on site, you should be preservative treating the cut ends to maintain that envelope treatment. The type of building this project is involved with is not domestic. Clearly, it's going to be quite a large building. It may look similar in construction to the photograph you can see on the right-hand side there. That's a CLT school being constructed. You can see lots of horizontal services with pooling water. You can see it's quite a big building taking time to erect. And it's being erected in Britain where it rains. And so we need to consider construction moisture and avoiding trapping construction moisture when we put up these large, complex and innovative structures. Nowadays, we're looking towards prefabrication in a factory to help with the skills shortage and increase time on, reduce time on site. And so we're building with more weather-sensitive materials that are coming to site, wrapped in polythene or other ways of keeping construction moisture out. That's all very well, as long as those membranes actually perform. When they start leaking or ripped or zone moisture into areas, they can actually work against us by trapping moisture behind those polythene membranes and allowing moisture to soak in. So we need to be careful. It is very much a balancing act as we bring materials and components with high levels of fabrication to site, we do need to be very careful that we don't trap construction moisture inside them. You can appreciate that horizontal external envelopes do present a challenge. I mean, look at that flat surface there, the flat roof. Who's responsible for keeping that dry during construction? Is it the erectors who have put up the CLT? Or is it the main contractor whose overall responsibility for the site? Or is it down to the roofer who's going to come along and put his membrane on there very shortly, one would hope? The answer really is it's everybody's problem, and they need to work together to form a solution. But it's not always clear where those liabilities lie in construction, and a lot of people are wanting to pass on that liability to another party to avoid the risk if trapped construction moisture does come back and be proved to be a problem further down the line. So concentrate on good detailing, speed of construction, and trying to keep the building as dry as possible during construction. The UK building regulations are quite concise in many respects, but they're also like that because they are designed to drive innovation and creativity in the way that they're written, so they're not too prescriptive. It's useful to note what our building regulations say about resisting moisture. They say the walls, the floors, and the roof of the building should adequately protect the building and the people who use the building from harmful effects caused by some of the things we've already talked about: ground moisture, precipitation, including wind-driven spray, interstitial condensation, so that's condensation forming within the structure, and surface condensation. And one that's often forgotten about, spillages of water from or associated with sanitary fixings and fixed appliances. So if the toilet overflows or the washing machine floods, what happens to moisture? When you design something, think about the 4 Ds of wall design as an example. So the first D being deflection. Now, these drawings here have got quite large overhangs on them. They are keeping the walls reasonably sheltered during rain when it's coming down. If it's wind driven, some of it will be getting onto the cladding, but the trend for clipped eaves and verges actually doesn't help with some of the good durability that we can get from good building design using overhangs. The second D is drainage. We want to make sure that if moisture gets past our cladding, that it can drain away from a timber frame without getting the timber frame wetter or allowing it to stay wet and maintaining a moisture content above 20% moisture content. So good drainage, and you can see the cavities on both of those drawings behind the cladding. If moisture does get into that cavity, we need to make sure that it can dry. So we're looking for a vented cavity to allow a transport mechanism to get that moisture out. And the 4th D is durability. The combination of the cladding, the membranes, the timber itself, are they going to be reasonably durable, working together to give us a building that's going to last as long as we want it to? The drained and ventilated cavity is critical. And so that right-hand drawing there, you can see the external wall cavity drains right into the ground, into what's labeled concrete fill. And in the brickwork, you can see a label open perpends at 1.5 metre maximum centre. So that's allowing air into the cavity to allow with that ventilation. On the left-hand side, there's a red curved line drawn across that cavity. And there has been a trend in the recent past, and still continuing, for people to put cavity trays at the bottom of the cavity. The idea being they're thinking they're getting that moisture, cavity moisture, out and away through the open perpends. That's all very well, but we need to think about what's actually happening below that cavity tray. And in that cavity space, below the cavity tray, we have those X's representing the timber, sole plate, and bottom rail. And that environment there is going to be quite high humidity from the ground and from lack of ventilation. And so we don't really want cavity trays in timber frame building design, because it causes potentially that timber decay at the most important timbers, which is what the rest of the building is sat on, the sole plates and bottom rail. We need to introduce air movement into that lower cavity space if we're going to be using cavity trays. So every space of the cavity has drainage and ventilation. This is another detail that you need to think about carefully. On the right-hand side, you can see the timber frame wall is sat on 2 brick courses on a beam and block floor. Now, those 2 brick courses are very important. They keep the timber up above the finished floor level. Now, if there was a washing machine flood or something like that, or even overzealous floor washing that we've seen in some buildings, particularly schools, and water can get in, it has the ability to drain and ventilate out. Now, if you look at the picture on the left-hand side, the contractor there has decided not to use those 2 brick upstands. He's decided to put his timber frame directly on the beam and block and then put insulation and screed around it. He's created a canal using DPC around the timber. Construction moisture gets in where that red arrow is. It has a very difficult task getting out. And I've been to sites where there's been decay in the bottoms of those walls, where the timber frame has been buried in concrete slabs, and over time, with high moisture content, decay has occurred, and then structural collapse has happened as well. So always think about where the timber is, and can it drain, and can it ventilate? You're going to be looking probably at various novel wall build-ups for your project here. You need to think carefully about condensation risk. You don't want to have interstitial condensation, which is condensation that forms in the structure. All walls breathe, and warm, moist air from the inside wants to travel through the wall structure and escape to the outside. And with timber frame construction, we do that using a drained and ventilated cavity, making sure that the more breathable materials are on the outside and the less breathable ones are on the inside. It's slightly more complicated than that. But you want to make sure through condensation risk analysis that what you're designing doesn't risk interstitial condensation, because interstitial condensation will allow moisture condensation to build up and put the timber at risk of decay. It also reduces the performance of insulation. Damp insulation doesn't perform as well as dry insulation. So be very careful with the novel membranes and wall build-ups you're considering, that you don't have a condensation risk in your building. Trap construction moisture, I've already talked about in a previous slide, but here's the reality of building in the UK. We want to try and make sure that the buildings are exposed for as short a period as possible. If they get wet, give them a good opportunity to dry out and back down to below 20% moisture content before they are enclosed with insulations and internal linings. You can see that center picture there, the communal corridor and the undulations in the floor. You can pick out the individual floor joists under that floor deck, where the floor deck is distorted because it's been, the OSB deck has had a puddle of water on it for many weeks, and that caused problems with the integrity of the board, but also would have caused problems with floor finishes. The right-hand side one showed an early closed panel construction that was built and brought to site. It had mineral wool insulation in it, and then a polythene vapor control layer. But the way the erectors fitted it together, you can see there's a nail that's been shot through the polythene, so that the wall panel could be joined to the sole plate on site. So if we're building with closed panel constructions or innovative construction, you actually need to think about how these panels are going to be fitted together at wall and floor junctions, while maintaining the performance of the wall panel that you're aspiring to. So what can be done to fight the British weather, to make sure we can get these buildings up as quickly as possible? So in the summertime, I mean, it rains in the UK obviously all year round, but the summertime has the advantage that there are spells of warm, sunny, windy weather in between that. So the moisture in the summer has a good opportunity to vent and drain away quickly. Whereas in the winter at the moment, you can imagine that once something gets wet, it stays wet for a very long time. I know building in the summer is almost a luxury that we often cannot build into a program, but it certainly does help with draining and keeping moisture at bay. Building vertically, if you're building a large block of flats, can you build them in phases so that we can get a roof on quickly rather than building everything horizontally and put all of the roof on at the end? Can we get some areas weather tight quickly? Managing water away from the building. So if we accept we're going to have to put some temporary weatherproofing in, let's make sure that that temporary weatherproofing doesn't just zone lots of water up at one end of the building, which gets totally saturated to the benefit of everywhere else. Manage that water out and away from the whole structure so it all stays dry. And take extra care protecting weather sensitive materials so that they do stay dry and we're not trapping construction moisture in them. Think about order of work. Look at these guys putting a roof on. This is a communal block of flat. This is a block of flats. The apex, the pitched roof is over the flats. The flat roof is the communal area and lift shaft. What happens when it rains during construction with that roof on? It's all going to drain onto the flat roof. There's no weather protection yet on the flat roof. So we're zoning moisture, rainwater into the communal areas during the construction phase. These things need to be thought about in advance as part of a pre-construction meetings and order of work carefully considered, because everybody is responsible for keeping the buildings dry as possible during construction. My talk today has been incredibly fast and pacey. There's a lot of information at your fingertips through the TRADA website, which is still live. The timber frame construction book, as mentioned earlier, is the go-to publication for detailing and information. It's about 250 pages rammed full of detailed text and drawings and information. There's also other books like the cross-laminated timber or the site timber frame pocket guide there that you might want to consider. And from a commercial point of view, if this project goes live or you've got other timber frame projects you're involved with, do consider getting Frame Check along. We're a commercial service, but we look very carefully and critically at where timber is in the building and help you improve the quality of the building, improve the performance of the building, save money, reduce callbacks that clients may have in the future if it's not built properly, and also help demonstrate compliance with authorities. So thank you very much for listening. I hope some of those points are useful to you in the project. So I'll stop sharing the screen.
Excellent. Thanks, Robin. Sorry, I was trying to unmute myself there and it wasn't it wasn't working. It was like hitting it. Come on, unmute. Thanks very much. That was really insightful. I mean, yeah, it's amazing when you show, you know, obviously what happens to timber as a result of, you know, moisture and moisture retention, etc. And just things that seem quite apparent, you know, in terms of detailing or like construction sequencing and the management, but they happen, right? They do. They're so obvious, but they happen. It's just making sure that we manage those associated risks all the way along the process, and don't think just because a piece of timber is treated that we can not treat it appropriately, right? Indeed, there's a lot that comes together on a building site, and communication is so important to get it running smoothly and efficiently and be there for the timber. Yeah, and yeah, as you say, the coordination of the trades and how they kind of work together in terms of how we manage that process productively, but at the same time manage it so that we treat the system with due care and attention during the sort of temporary phase, so that when it's in the finished phase, it acts as intended. Yeah, and it's not just timber that's like that, of course. It's all forms of construction can suffer, and so we've all got lessons to learn from it. Perfect, cool. I understand you've got some family matters, but you're going to hopefully attend later on for the Q&A. Is that That's right? I'm planning on dipping in for the Q&A at the end. Perfect. Okay, I'll let you deal with whatever you need to deal with as such, and then we'll hope to see you later on. But thanks very much. Thanks, Robert. Perfect. Cool. Jay, we're going to move on to yourself now in terms of building a passive house. Now that we understand, you know, the need to, you know, manage activities with regards to moisture and durability, etc. So yeah, I'll hand it over to yourself to take over and run us through your presentation. So thank you very much.
Thank you. I'll just try to share my screen if I may. Right, so I'm an architect by profession, and I'm the author of the Passivhaus Handbook, and also we build using the PH15 system, which is a timber frame system for building passive house buildings, and we won the Ashton Award in 2020 for scalable climate change solutions. So that's where I'm coming from, and I've been asked to speak about building a passive house. So this slide, it shows you all of the targets that you're meant to achieve, these here on the one side, but I'm not going to get you to look at that and think too much about that, because really with passive house, you just know the basic principles, and if you apply the basic principles, you'll get the results. And at the point that you're building, anyway, someone will have modeled this in PHPP, in the energy modeling software. But there's also these 3 levels in passive house, and again, I wouldn't worry too much about them, because everyone has to go for the classic first. In other words, whatever you're doing, you always have to do fabric. Getting the fabric right is always the first step. And then if you get that right, then the plus certainly, and the premium follow after that, and that's to do with renewables on site. And the principle with passive house is that you're trying to conserve heat loss as much as practically possible. So you've got lots and lots of losses of energy in a building, and you just try to reduce them down as much as possible. So it's like a thermal flask, and that's why it's passive, really. It's a passive way of reducing your energy. And these are the 7 ways that you go about doing it. And I've actually summarized these into just 3. So the first one that I would say, and the most important one, is that you have to have a contiguous airtight layer and insulation layer. That is the absolutely main thing that you need to understand. And that's easy to say, but not so easy to do. The next thing is you have to have controlled ventilation. And the majority of our buildings have uncontrolled ventilation solutions. So you must have a controlled ventilation solution, or an MVHR with heat recovery. And then the third one is you just must manage the sun. And that's in the winter when you want to gain some energy, and in the summer when you want to watch for overheating. I've tried to make it into a little sort of word play to make it really, really easy. And I came up with Vaticans at the bottom there, which is a bit silly, I know, but that's ventilate, airtight, insulate, contiguous, and note the sunshine. And that really tells you everything you need to know about passive house just in that word. So, you know, don't overcomplicate it, is my message to you. I'm just going to give you, before I start on the actual on-site, it's the sun and glazing that tends to be overlooked in passive house and how key it is. And this little diagram here just shows you the climate, how much it's been warming since the middle of the 20th century. So if you build your building where this blue circle is, it's going to be there for 60 to 100 years. So if you model it and think about the climate today, it's not going to be the climate of tomorrow. So it's very, very important that we model our buildings for future climate. It's absolutely essential when you talk about a passive house. And because of this, it means that shading is highly likely to form part of any design solution. I noticed there was some shading shown in that sort of diagram of the building that you're supposed to be doing. I know that was only a diagram, but it's very difficult to shade glazing that's full height. That little diagram in the competition showed full height glazing. You can't really do it from above, actually. So if you're going to use a lot of glazing, you must think about mitigating it and shading strategies and how you do that in a design, well, in an aesthetically pleasing way. And there are obviously guides, like the Passivhaus Trust gives you guides about how much glazing you should really have, ideally, and certainly you shouldn't be over glazing. And you can think that glazing is important because it's part of the airtight insulated envelope. If you don't have the right windows, then you've broken your airtight and insulated envelope, your contiguous layer. So that's why windows are critical. They're not an optional extra. So passive house is good for the planet's health, certainly, and it's good for your health. My question here is it good for timber too? So I want to talk about why passive house is specifically good for timber. especially in the light of what we just heard. This is a slide from the Passivhaus Trust, and it shows you why Passivhaus is good for you. So all of these things, these criteria here, are all to do with that Vatican's thing, like surface continuous insulation. That means your surface temperatures are kept in that range. The ventilation, the being airtight, all these things, and then it delivers certain effects, and a lot of them are to do with moisture. Well, no condensation of mold is one of the effects, and also removing pollutants in the air is another big one. And the results is you have this healthy indoor air and very comfortable building, and you avoid these alternatives, problems that we've got in existing housing, terrible problems in this country, where we have a lot of fuel poverty, we have a lot of cold homes, we have a lot of asthma, we have a lot of mold, and we have a lot of discomfort. So really, we're just talking about quality buildings. That's what I would say. We're just talking about building quality buildings. So I'm going to now go on to Onsite. This is our system and the way we build our walls. So it's built with an I-joist frame. And this is where you're going to have to start. You've been asked to build in timber, so you're going to have to think what your choice is going to be. So we've gone through a choice system ourselves and asked ourselves a few questions. So I hope by talking through the sort of decisions we've made will help you, whatever way you decide to build. It'll help you because you have to go through those same key questions if you're going to do a passive house. And the first thing I would say is waste. Timber is a precious resource, and you've got to think about circular economies. You've got to think about replanting. Just using loads of wood wastefully is not going to be a good solution. You've got to think, we get our wood from a monoculture, but we actually replant diverse habitats through the Woodland Trust. So you try to think circularly what you're doing with the timber that you're using. And we work with a company called CITU who are very keen on using all the logs. So when they cut timber, they use all of the timber for the different materials that are used. And you know, you have to think about where your timber comes from, how quickly it is to be replaced. I'm not very keen on oak in buildings because it's very difficult to replace an oak tree. But if you're using something like spruce, obviously it's much more quick to regrow and replace. And then how efficient is your frame? There's something called a timber fraction. You know, in this sort of system where you're using laminated timber, these are the 6 mil laminations at the end of the I-joist. You've got a very strong use of timber in a small section. You've only got an 8 mil web here. So in the end, most of that wall that you're looking there is actually insulation, not structure. And the more that you can optimize that relationship, the better for the environment and the better for price actually as well. And here's a little section through the wall. And I'm going to, the next thing you have to think about is where will your airtight layer be? So the two most important things are the contiguous airtight layer and the contiguous insulation. So the first one you think about is the contiguous airtightness. And we live in a temperate climate, so the right place to have your airtightness layer is on the inside of the structure. So you can see here, this is the airtight layer here in green. It's on the inside of the wall structure. And basically that is acting as your vapor control layer. And because moisture in timber structures is so important to manage well, this is ideal because it blocks. You need to have a moisture block here to stop any moisture from inside the building entering the structure. So this airtight layer is doing 3 things in one in this case. It's acting as the airtightness, it's acting as a racking board, so it's adding structural stiffness because these I-joists, they're small sections, so they're carrying lots of load vertically, but they can wave about otherwise in other directions. So this part provides excellent racking strength, and it's also your vapor control layer. So we're paying a little bit more for our airtightness layer. It's not a cheap board, but we're doing lots and lots of things with it, things that are essential for timber. So the first thing is you always have to ask yourself is, where is my airtight layer and what is my airtight layer? So you know where it should be, and then you've got to think where it is. And in this case, we also protect our airtight layer a little bit from the final plasterboard finish by providing a little service void. So we're hoping then by that we're protecting it from damage over time. And at some point, that near the end of the project, that's going to be actually tested with an airtight test. So you're not going to get away not doing it properly. So thinking of an airtightness layer that is simple to do is going to really, really help you and help the guys on site to do a good job. I'm going to show you a project in a minute that's not simple, and then you have to take responsibility for it if it isn't simple. Right, then the next one is insulation choice. So again, you're doing a timber frame building, but you've got to think that in this particular case, and in any passive house building, the proportion of the wall and roof is going to be predominant insulation, not timber structure. So if you really want to make the most of wood, then you have to think about, what am I actually going to marry with my wood, and what's going to work well in terms of insulation. And you've got to think about how the insulation is going to be fitted. You've got to think about the embodied carbon of the insulation, because it's a huge amount of it. And how easy is it to install? Are you asking people to install insulation that is really tricky to install well? And again, how will that insulation interact with the timber when it comes to moisture? Because timber is a natural material, it needs to breathe. We've learned it needs to remain dry. You don't want to marry it with insulations that are going to exacerbate things and trap moisture. So we use natural insulations, predominantly wood-based insulations, mostly just loose wood fibres and wood fibre boards. So on the outside, we're using a wood fibre board, as you can see in that picture, and that's the sheathing layer on the outside. It's very, very vapor permeable, and it's allowing any moisture. We saw some horrendous photos of how much moisture happens on site. Well, we can't stop things getting wet on site when things are built. We can minimize it, but we can't stop it. We need to let that moisture dry out over time, and therefore you need to allow your structure to be vapor permeable to the outside. So we're ensuring it's very, very vapor permeable to the outside, but vapor impermeable to the inside. So those are the principles that you're working with. In this case, you can see here we're using pre-cut bits of insulation, like between these two eye joists, so that they come to site pre-cut. Nobody has to cut it, they just pop it in. And that means that we don't have problems with quality on site. So we're always trying to think, how can I maintain quality to ensure thermal continuity in all locations? This is it going up. So ours is not panelised. You could panelise it. There's more than one company in the UK who uses this sort of system, but they panelise it in a factory. We're pre-cutting it and flat packing it and sending it to site. So we're relying on on-site labour, which we are training. So you've got to think, if you're going to rely on on-site labour, then you need to provide some element of training and uplift in skill, like you're doing by attending this lecture. So you can see this is the beginning of the wall. It goes up very quickly because it's all pre-cut. And then you can see, because we're a system, so this is the advantage of using a system, is we have very high level of information for the builders on site. You can see they have very simple erection drawings. They can see what bit of the building they're putting up. They know each of these elements is numbered, and they're just putting it together. And there's a very good 3D install manual, and they can see step by step in 3D how they're going to go about putting up their building. And that's the advantage when you're not doing a one-off solution and you're using a system that's repeated lots and lots, so you can have quite sophisticated information related to it. And this is a building here. You can see this is quite a big space being created. You can see here we are actually, because of the moisture issue, you can see we are asking people to put a tin hat over our structure. So we've got a tin hat that's keeping the place dry. It does cost money, but it means nobody's losing any time during the build. They've got ideal conditions. It's good for the people on site, and it's good for the wood. And then it's good for air tightness and quality of work, for managing the quality of work. So there's the frame, the eye joist. There you see the airtight layer, and there you see the airtight tapes between the joins. And then you can see the beginning of the stud work for the service void, and they're running their electrics in that little service void as discussed. So you can see very big spaces can be created. And you can see how neat and tidy this sort of building can be. And this is what you want. You want something simple. You want something that's understandable. People can recognize the airtight layer. If anyone penetrates the airtight layer, they simply add a grommet, and then it's dealt with, and you don't have any leakage. So here's another detail. When you're building, you're sort of moving away from traditional ideas where you might put an intermediate floor and rest it on the outside wall. Now, this is obviously an internal wall, so that's fine. But on the outside wall, we don't want that to happen because we're then interrupting the insulation and we're interrupting the airtightness layer. So we use a ledger beam that gets bolted through to the flange of the eye joist. And that means that if you look at the little section of the drawing here, you don't interrupt your insulation, you don't interrupt your airtight layer. And that's just the principle of Passive House all the time. At every junction, you're trying to do that, and you're trying to do it as simple as possible. And here's another view of the space. And you can see here, this looks how tidy the space, if you keep to something simple, how tidy the space can be on site compared to some of the photos we saw on the other presentation. And we're trying to, if you're creating big open spaces, we're trying to use timber, but you can see how deep the timbers can become. And these are laminated veneered lumber, LVL timbers. And in this case, because the architect wanted such big, this is a 3-story height space here, we've had to use a steel. We've tried to minimally use steel because it's high embodied carbon and it's expensive, but it's interrupting the airtight layer. This is the only way to do it. And we have to manage that. So you can do complicated designs. This is what I'm going to talk about, complicated shapes and complicated designs for Passive House, but then you need to take responsibility for managing it. And you can see here, we've had to do really quite a lot of 3D drawings to support this shape. So we've got a butterfly shaped funny roof here. Then we've got a V-shaped roof behind here. And all of this has to be managed step by step, how they do it to make sure they never break that airtightness layer and they don't interrupt the insulation layer. So it looks very neat here, this shape being created, and it's got a very, very good airtightness result, but there was a lot of work to make the building more complex. So yes, do your complex building if you want to, but don't leave it to people on site to sort it out, because then you'll get things an absolute terrible mess. So that's all about buildability. And here's a flat roof going to just a little tiny flat roof. And we've changed the air tightness layer here from a board to an intelligent membrane. And that's because if you do a flat roof, you can't get any breathability to the outside because you have to put a watertight layer on. So these sort of membranes are quite good because they do allow a little bit of drying to the interior. But you can see where we've got round a window, we're choosing to use these natural insulations that just fit in to the webs of the eye joist. So we're using here a little bit of sheep's wool and a little bit of wood fibre. But you notice when you're using these natural wood-based materials, their performance, their thermal continuity, much lower than oil-based insulations. And that's why people favour oil-based insulations, but they're very high in embodied carbon and not very recyclable at end of life. So we're making preferences to use wood and natural materials, but we do have extra thick constructions as a result because of those choices. And here's the flat roof section through. Here's a way of doing a flat roof. Tabba was saying she didn't like flat roofs so much, or indicating that she didn't. But really, the safest way you can do a timber flat roof is to not insulate in the timber roof. So you've got a timber structure, and then all your insulation is actually outside the structure. And you are using high performance insulation there because you're making sure there's never any risk of any interstitial condensation in your timber, because by the time it gets to the timber, it's warm enough. And that is non-breathable, and it's going on the outside. And there's your, and the reason you have to do this is because, of course, you have to have a waterproof layer somewhere that's not letting any air or vapor out. So you have to think differently when you do flat roofs. You could try and introduce a ventilated void in this zone here so that your timber can breathe, but then you have to maintain it. And that's not always the easiest thing to do. So flat roofs, their own challenges when you're using timber. At the ground, you have another challenge with timber. You've got to keep your insulation continuous. So I'm giving you an example of how we do it here. And the problem you have is we insulate underneath our slab. This is our slab. And then we have some insulation that's in the cavity, the substructure wall. This is what this is here. And then we have a problem because we have to take all our loads from our slab down into our footings. And here is where we have a problem when we get break, we spoil the continuity of our thermal envelope. And then we have to find special little products to help us to do that. And there's very, very few products that are both load bearing and insulating. And so these very, very tricky, this is probably the most tricky place to ensure continuity. We're using this black product here, which is actually recycled glass. And there's one or two, there's something called compact foam also. There's one or two things like that you can use, but it shows that you have to find sometimes a special product to just make sure you don't end up getting a thermal bridge. So I hope that's been a bit of a whizzing tour through some site photos and why we do different things. And I just wanted to make this point that getting that fabric right and that contiguous insulation and that contiguous air tightness on site in a tidy site with as simple as possible details, or if you go off-piste, that you really take responsibility for what you're doing, or if you're doing a flat roof, you really take responsibility for that flat roof design. Once you've done that, then you're on the ideal pathway to net zero carbon. And you can then begin to think about your renewables, whether you put photovoltaics on your roof, or whether you have air source heat pumps, or all these other gadgets. You're obviously going to try and use electric energy because that's the energy of the future. But the passive house fabric first is going to set you up to then move to the next step, which is to try and get to net zero carbon. So if you consider the embodied carbon of the frame and the insulation, and if you manage the moisture risk well, in whatever way that you choose to propose for your building, and if you take responsibility for any design complexity that you introduce, then Passive House is really excellent for timber health too. So not just for the planet, the environment, because of climate change, for us as people, but also for timber as well. And there's a picture of that finished project, and you can see, that interior space. Does it look like a passive house? Not particularly, but you can see how on the actual structure on the outside that you've got very thick. You can probably pick up even on this flat roof bit. You can see how thick the build-up is. To use timber, to use it in a moisture safe way, you get slightly different dimensions. You've got extra thick structure going on, and your aesthetic has to follow that. You have to follow the requirements for keeping the timber safe, and you have to reflect it in the design. Okay, that's brought me to the end, and I hope you found that useful.
Perfect. Thank you very much, Jay. That was really insightful, to be honest. Starting off with the kind of fundamentals of Passive House, and then going right through the sort of rigors of the detail and how to manage your layers. I think, as you say as well, using those natural products can, ultimately result in a thicker wall, etc. But it's just about embracing that, really, isn't it, for the benefits that provides. We often marvel at the thickness of stone walls and castles and stuff, and go, look at the thickness of that. And then in the more modern structure, it's almost like, how thin can it be? When actually you can get a good chunky system, which is a healthy built asset, right? And
you can go with the aesthetic of that, and it can be very attractive on site. And but it's the most common thing I say to people coming to me with designs is they design 350 walls. And I will say, you've got a 450 to 550 wall. If you're going to use natural materials and you're going to use timber, generally you're looking at a much thicker wall.
And interesting in that as well, as you say, using this the engineered products, if you're going for a closed panel system, etc., those engineered products, provide the opportunity to do that, because you can get the thicker wall, and you're also optimizing the use of the materials in terms of how they're made up. So it's having that sort of holistic thought process. So, and I did like your Vatican's it's very tempting, isn't it, to say Passive House is the holy grail of construction or something, but maybe I should
the Holy See, the Holy Grail,
maybe keep my jokes to myself, right? But no, that's fantastic. Excellent. Jamie, if you don't mind, we'll hand over to yourself now, and looking forward to you telling everyone about the good work that CITU are doing. So please take ownership of the screen and give us an insight to what CITU and building sustainable communities. Thank you.
Great. Can you see the screen now?
Can, yes, indeed. Yep.
Okay, great. Yes, and thanks, Ava, for the talks. So what I'm going to do is give you a bit of an overview of the work CITU is doing, which is really focused around creating a sustainable community in both Leeds and Sheffield. So yeah, I'll start by sort of explaining the work CITU is doing. I'll touch on our build system. I won't go into too much depth on that. Talk about how we deliver our homes, which is a bit more unique in the passive house industry, and then then talk about what the places are like to live in, what the communities are. So CITU as a business is very much purpose driven, and it's towards accelerating the transition towards zero carbon cities. So we're doing that through the built environment. So it's through construction using low embodied carbon materials, as much timber as possible. Doing it through energy use, so building low energy buildings that don't require an awful lot of heat, that are airtight, following all the passive house principles, and then also creating places where which are walkable, cycle friendly, where people don't depend on cars. So we're locking in ways of transport interaction with your city that are going to be there for generations to come. So we're looking at all three and taking quite a holistic sustainability approach. The homes we develop are very similar to the work Jay's doing at Passivhaus 15. We use an I-joist construction, timber frame. We do airtight construction, so to 0.6 air changes an hour, and all in line with the passive house principles. And then as a business, CITU, we're vertically integrated business. So what that means is we have a good control over the product we're creating. We're primarily a developer, so we do the land acquisition at the start of a project. We also have the design team. We've got a timber frame manufacturing facility, so we pre-construct all the wall and floor panels in a factory, so we can erect them on site quicker. Yeah, we've got an erection team that puts that together, and then an assembly and fit out team, which finishes off. So what that looks like, kind of taking you through the stages, is the designs are done. Well, they actually start earlier on than that in models and sketch form. Then that's taken with 3D modeling, and then broken down into every component, which then goes into the factory. So what you're seeing on the right there is a TV screen in the factory of a floor cassette that's about to be assembled. Environmental modeling is something we're starting to look at here. Yeah, Jay, I hadn't seen the 7 principles. I'd only come across the 5 before, but I like that. And manufacturing. This is our manufacturing facility. So building everything, it's pretty much everything in timber. We use timber insulation, timber I-joists, and floor deck, OSB on our walls. And then this is the erection process. So generally it'll take around about a week a house, and we'll erect buildings in a block of 4. And at that point, it's handed over to an erection team, a fit-out team. Sorry, so that's a team of around 6, and they're multi-skilled. So you've got a joiner, a plumber, an electrician, and between them, they'll fit out a house in about 4 weeks. So working around each other with areas like kitchens where it requires a joiner, electrician, and plumber also be working around each other. That's where this has its advantage, because they're a team. They can take responsibility, as a team, and it's encourages the culture of ownership in construction, so people not passing on problems from the previous trade. Yeah, so now I'll talk to you about the principles of the Climate Innovation District. So yeah, it's a visual of the Climate Innovation District, and it's if anyone's familiar with Leeds, it's about a 15-minute walk out of the city centre along the River Aire towards the east, and CITU generally develop in brownfield city centre sites, so sites where people can get by without a car. You've got your amenities nearby, and but not developing greenfield sites and kind of perpetuating like sprawl. And the methodology of development as well is quite different from the norm. So typical house builder is doing your low density stuff. That's there on the left, where everyone gets a garden, a garage, a detached house with 2 parking spaces up the front. And just it's a very land hungry way of developing. So by its nature, it means you're dependent on a car to get out of that particular estate that's being developed. And then the other common method of building is the high density model, which is what you'll see in a city centre, which is basically stack them high and get as much floor space out of the site. That doesn't particularly encourage very communal living. It's unlikely in that kind of setup you'll know a lot of your neighbours. So what we're kind of pioneering is a medium density development model. So it's a combination of the two, and so you've got your houses close together, and no private gardens, all shared landscapes, and all parking is out of sight if we can't get rid of it. So this is a view of the Climate Innovation District as it's planned. It's around about 800 homes, and you can see all the green space there is car free. You've got a road coming in there to go to an underground car park, and then you've got a road across there. But other than that, this is all a walkable landscape, and it's open for the public to walk through as well, creating a through route. And so this is also really designed to be a community within Leeds. So you've got here, this is a multi-generational building where you've got a care home, a primary school, and that's very important to make sure people can operate on their daily lives without depending on a car. We've also got kind of a mix of there's an office. You've got our manufacturing facility is in the middle of the site as well, and kind of a mix of commercial and residential. So so it's not single use. It's not just residential. This pedestrian bridge, if we come back to it, it's over here. That's one of the first things we put in the site, which kind of creates that link to the city centre. So emphasising the walking routes. This is a view of the shared green spaces, and what that does is it's actually a real off-putting feature for a lot of residents when they come and view the houses. They kind of have in their mind an idea of a house with their own garden, but I've spoken to a lot of residents after they've moved in, and that's actually been their best feature is the shared space, and it allows them to all get to know each other. So during lockdown, they all have a WhatsApp group as a community, during lockdown, the older residents felt safe that if anything happened to them, they could depend on their neighbours to get food for them, and really created a really good sense of community. So here's another view of these shared spaces. So everyone's front door comes out onto these patios, and you've got your cars hidden underneath this. The other area of is sustainable drainage. So yeah, as buildings typically drain, then all the water basically goes into the during heavy rain is collected, goes into the sewage system, which can cause it to overload. So sustainable drainage is about having a permeable surfaces that slow that water down. And then this is kind of the opportunities you get with the shared landscape. You can create spaces for sports, well-being, that everyone's sharing space rather than an individual garden. So in terms of setting up a community, that's quite a core part of what we're doing. So there's a community interest company that facilitates the residents. So they buy into the house, but they also buy into the wider community. So and that community is responsible for the upkeep of the communal spaces, but it also does things like buys energy together as a group, which allows people to get better prices on energy. Like solar panels as well. There's site-wide, the solar is shared on a site-wide basis. So it allows everyone to get a discount on their energy. And yeah, it encourages everyone to chip in and kind of take ownership over their own landscapes. And then here are some words from some of the residents. I'll just kind of flick through. Yeah, so that's my presentation. Thanks for that. I'm not sure if that was a bit too short, sorry.
Perfect. Yeah, not at all, Jamie. I wasn't timing it per se, but that's okay. But I thought that was really useful. It's really interesting development, you know. I think it's really intriguing what you've set up. It is, yeah, it's got a kind of vertically integrated feel to it as such, you know, from the factory through to the development, etc. But you touched upon a number of other additional areas which are, yeah, useful to think about, you know, like the community ownership model and how that works, and that, you know, shared ownership. You know, we've been hearing more of that of late, and yeah, it's just interesting to see that, you know, how that works, etc. And then other things like suds, an important aspect, and using it so the water runoff from the houses essentially is getting fed into the river. It's not going into the sort of sewage system, right? So you've got that set up, right? Yeah,
that's right. Yeah,
that's really interesting. And then just like it intrigues me around the whole sort of planning and building regs, because it seems like there's kind of innovation in there and pushing some of the boundaries, especially often these things happen maybe on like one-offs and small scales, but to do it on larger developments is kind of shaking the norm a wee bit, you know.
Yeah.
Cool. Perfect. Let's have a wee look at the chat actually, just to see if there's any questions. There's a few in here. So Ocean, he's got a few questions here. She's wondering which foam glass product you use to thermally isolate the foundations from the building.
It's just a foam glass block. So yeah, if you look, you go to the Passivhaus store, just Google it, foam glass, FOAMGLAS, and it comes in suitable 100 mil wide for a block wall, and you literally lay it as if it was a block onto a mortar bed.
Cool. He's saying he struggled to get like an EPD for it. I don't know if you had similar issues in terms of getting the environmental performance declaration certs for these products, or Yeah.
Not with that. We haven't. No. We haven't. No.
Yeah.
It's been fine.
Yeah, no worries.
Sometimes it is difficult when you find something innovative and people get a bit suspicious. But in that case, no, I think it's a very good product.
Yeah, yeah, and obviously in the engineering side, things from like you asked the question about compressive loads, how the compressive loads were managed to avoid overstressing the insulation before beyond crush strength.
You might have noticed in my drawings that they're done in piers, and then we fill with Celotex in between. And if there's a lot of load coming down, but with timber, your loads are obviously reduced usually quite radically anyways, but they just use more foam glass if there's more loading and less, and the piers get separated out. So we optimize the thermal efficiency of that detail by having the foam glass in piers, because it's not as good as Celotex, obviously. So the more Celotex you can have in between the piers, the better. But it can carry quite a lot of load. And you've still got load coming down the external substructure wall as well, the external leaf as well.
Yeah, it's interesting, as you see, especially with timber structures, you're obviously, you know, reducing the building weight, you know, relative to other materials as well.
I mean, one of the things we've been looking at, because if you do the embodied carbon calculations for something like Jamie's doing or we're doing, all of the embodied carbon is tending to go in the ground, in the concrete and in the insulation in the ground. So if you can get rid of that altogether, obviously it's even better. So then you have to look at making floor cassettes, and then you have to look at some sort of like mini pile type situations. But there's innovative little mini pile situations coming onto the market as well. So if you can do something like that, you can massively reduce, you increase the amount of timber use, you get rid of a lot of the concrete and these special products like foam glass and all the cement and the Celotex, and you just go back to timber-based products with, you know, with mini piles. But I mean, on a big building, although this isn't a huge building, so you could definitely do it on a building like this. But that's more innovative, again, structurally. And it's about life. You know, if you do anything different, it's like with timber, people are worried about moisture, they're worried about fire. And then when you go to start putting mini piles with metal piles in the ground, they worry about durability because it's a new thing. So anything innovative, the building industry is generally conservative, and you have to battle against that conservative nature. And then those of us who start doing these things, like, you know, Jamie's doing a new thing with what they're doing there, we've been doing a new thing with our system. You have to battle being the first and try and break down some of the walls of resistance, the business as usual sort of, you know, pressures.
Yeah, absolutely. Yeah, and Jamie, you commented on it in terms of this in that sense as well, because you're developing on brownfield sites, so presumably ground conditions or something that came into play. And you know, yeah, any comments you wanted to make on that?
Yeah, it's something we're doing a lot of work at the minute on, and yeah, Jay's right. Most of our carbon is going into the ground, and it's the concrete. It's also the insulation you need to put in the ground, we looked a lot at those screw pile foundations, which is there's a great company called Rapid Root who just new to the market, or relatively new. And but the thing is, on brownfield sites, it's a bit more tricky, because what you've got is you've got a lot of voids in the ground. So and you've got so sometimes the earth needs turning. What we found is most of the time we will need concrete to use our site. So we're going down the route of looking down low carbon concrete routes. And yeah, where we can, like if we've got a podium, can we start to use like a floor cassette there, rather and just reduce the amounts of concrete we use in certain areas. But it's very difficult to get around on a brownfield site.
I can imagine. Yeah, I mean, Rapid Root, for those of you who don't know, they use what looks like scaffold poles driven into the ground in a circular sort of pad. But I really like it because it means that you could reuse it in the future. It could all come out of the ground and it all could be reused. It's all potentially recyclable, but there's no real data for, like, there isn't a lot of data on LVL timber actually. So we over-engineer the LVL as well, but there's not a lot of data of putting metal into the ground. So you try and find evidence to use some of these things, and it's a bit difficult.
Yeah, yeah. And as much as the site we're talking about here isn't a brownfield site, it's actually a sort of greenfield site, but these considerations are still important, because even that, you know, in the future, even like if removing it, you know, from the site, and, you know, any trace, or making sure that, you know, the landscape isn't overly disturbed, or managing the water coming off the envelope, etc. You know, so it's how you design the building, so that, you know, there's that whole design for manufacture, assembly, disassembly, reutilization, all of that stuff, you know, so it's giving it, you know, full consideration to the.
Yeah, I mean, the other thing about if you put concrete and stuff down, it's high embodied carbon, but it's very moisture safe. Do what you like to it with the moisture. So if you get a washing machine leak, or you get, you know, some plumbing mistake and it flood, you know, you're not worried, are you? But as soon as you put timber cassette floors in and you have a leak, you've got a whole different issue, haven't you? So you reduce. So there's these issues always. There's lots of things to think about. There was a new bit of technology one of my clients was using, where it's like tiny little sensors that you put under your washing machine and under any sensitive sanitary thing, and it would immediately signal to your phone. And it was linked also to the water pressure. So if there was any drop in water pressure in the building, it would tell you you probably have a leak and what the size of the leak might be. So it's things like that in the future when you're using timber, or if you're certainly going to use timber around the floor, you know, things like this in the future might really, you know, things like this always interest me, you know, people thinking of new ways of reducing risk.
Yeah, that's what we're trying to do in the cat build. You know, the building behind me, as we're building at the moment, is introduce sensors into it, principally on moisture measurements. We're working with Story Enzo to do that. But I was sort of talking about it at the start, indeed, but even just trying to get the sensors installed has proven difficult, just because they're not part of the build program, right? And so that it's been a bit of a headache. We'll get there, but part of the reason we're doing it is in line with much about the conversations on, indeed, around this sort of insurers and warranty providers, and, you know, convincing them that these technology, you know, timber technologies can be used as long as you design in detail it appropriately. But it's trying to provide that evidence base and make it transparent.
I mean, there's no reason, is there, that these timber buildings couldn't be 100 years and more if they're designed well.
Yeah, absolutely.
And if you do it right, Passivhaus drives you towards good moisture management. So, you know, it's a good match. Yeah.
Tabitha was just building upon that, Robin, in the chat there. You know, is there anything from your perspective to watch out for, and the students should have concerns, you know, if they decide to use screw piles or another foundation type system with regards to moisture management? Or is there things that you've come across from your experience, or in terms of
watch out for point loads?
Mm-hmm.
Make sure that they're picked up with the location of any screw pile directly below those point loads, and same with foam glass, I guess, as well. That product can cope with whatever point load is going to go through it, and be fully aware of timber in relation to ground level. So if you've got something on screw piles, what is your floor detail? If it's going to be timber, make sure it's got good through ventilation.
Yeah, I'd probably say on that one as well, where that tripped us up is the detailing to the front door, and getting a accessibility access, where you need to have a level threshold. And when you have your 150 mil of ventilation plus your 300 mil of floor, then you're already half a meter off the ground.
At
trying
least
to get that threshold level.
Yeah. Mm.
Yeah, it does make using timber floors very challenging in today's world, and we see very few of them in reality because of it. And that's no bad thing, because if it's not detailed properly, then we end up with decay.
Yeah.
That's why you see Americans, they have the verandas, don't they? And then the steps up to a veranda, and you see all that. Obviously, we can't do that with accessibility. You have to find some way to getting up to a veranda type deep. With a public building, it's quite nice because you usually want these external spaces. So if you can elevate them and get up to them in your landscaping, then you can lift the building up off the ground a bit and really reduce your carbon footprint down.
Yeah. Anything on, any comments just on like thermal mass, you know, from a sort of, you know, in a sort of passive house design and how you use the, you know, because obviously if you use a concrete foundation or whatever, you're getting more thermal mass. And is that, does this come into consideration, or what's your thoughts on introducing thermal mass into timber built systems?
And my own feeling is you don't need as much as people think. And if you have too much mass, you can end up storing heat in that, and then it can just slowly release and actually exacerbate your overheating. Mm-hmm. And something like a timber frame, like actually both, Jamie, what we use is similar. If you have it filled with cellulose or wood fibres very densely, it's actually a medium weight building. So there's a lot of mass already actually in the timber. It's not as light as people think. So I don't think it's really such a big issue. It's more about removing the heat. You know, you're removing the heat anyways through the ventilation system constantly. You're refreshing the air all the time, taking it away, taking it away, taking it away. And that's the key thing, is the ventilation system is doing much more than people think. It's removing moisture, it's removing heat, it's removing, you know, and it's providing you fresh air from the outside all the time.
Well insulated, airtight building will work well in the summer as well if you keep the windows closed.
Yeah, it'll keep you cool in the summer and warm in the winter if it's done well.
Great, perfect. Well, I think we've reached the sort of near the end of the seminar, really. That was quite good, having the time for conversation and discussion. I think it was a really good range of presentations, actually, starting off with the sort of moisture management, durability, you know, thinking about the detail and for longevity, and giving that due consideration. Just simple things like, you know, with your timber clad, and you might be elevated, but you still get splash off the foundation, right? So it's not just as simple as putting a gap in there. I know that from my own experience of fencing, right? So I'm looking at my fence every now and again and thinking I should just have made that a bit higher, and then, you know, I'm meant to be an expert, you know. But until you actually build something and look at the practicalities of it. So that, you know, and then, as you say, Jay, you know, the experience of what you've done there, and you know, the sort of you know, going back to the sort of Vatican's piece, but you know, the sort of understanding that the sort of high level piece, but then the sort of granulation of the detail, and how those things all sort of work together to get a system that operates well, and thinking of holistically. And then Jamie, the really interesting work that you're doing with CITU to build out essentially, you know, sustainable communities and a different approach to living in many respects, and that sort of shared ownership and co-ownership models. And the other things that that were built upon the top of that as well, especially when you're going for larger scale projects, which the building that we're speaking of will be, in terms of how we're managing moisture, and also from a SUDS perspective, in terms of how you manage the offshed of water as such. And then sort of filtering it, and then being able to release it back into the water course, so from a sustainability perspective. So loads of great stuff in there. So with that, I'll thank you all very much for your time. You're most welcome to hang on, but I'm sure you've got a cup of tea or a bite to eat or whatever it may be. And then Tabitha and I will pick up if there's any further questions on the sort of team building, etc., with regards to the challenge itself. So with that, I'll thank you very much for your time and bid you good night.
Cool, thank you. Thank you for having us.
Thank you.
Cheers. Ossian's got his